Hello, hello. Good Saturday morning to you. I'm just going to make sure that I am rolling here. Okay, looks that I am. Um, Drop any comments, questions, whatever. This will be a fairly free flowing and we'll probably only go, about a half an hour unless there's more questions. Or if I get on some sort of roll, I guess you would say too. So, I want to get one more screen up, so just hang tight with me. Um, so today I just want to go over what um, what I would do differently for getting started, specifically in the digital side of things. But I also know that there's a lot going on the educational side of prosthetics and orthotics as well. And so I think that is another important thing to talk about. And let me get this screen. Hey, thanks, Ben. Let's see if that's better. There we go. Appreciate that, Ben. Good to see you on. So, when I was in school, everything was via a certificate program. So you had your bachelor's degree, you would go get your certificate, and then you would do your residency via both prosthetics and orthotics. There was nothing that was a combined orthotic and prosthetic. And so I would say my plea for kind of the next generation of clinicians is really take a look at what it's going to cost you and try your best to do it without student debt or very little student debt. I don't know what that looks like. That's something that I've been struggling with some other people that I know, some dear friends of mine that I know that are looking to get into the field. And it's quite an interesting conundrum because some of these people have a bachelor's degree, say in engineering or something like that, where the entry level into the market, because there's such a demand for engineers, the salaries are so good for those compared to just getting started in the orthotic and prosthetic market. And so I think that is something that we're going to have to take seriously, not only in the education side of the prosthetics and orthotics, but also um, how are we looking at recruiting to people? Can we actually do some things like what has been done historically through, say, the assistant program and such, where it allows people to not only get experience, use their talents in whatever way possible, and then also do patient care. And so it ends up being almost like a physician's assistant side of things. So if I had to do it over again, I think it would be um, I had the opportunity to be essentially debt free within a very short amount of time. I think, and people will laugh at this. I was newly married. I just went to school. My wife was working in a bakery in California for $10 an hour. Our apartment, which was roughly 600 square feet, was I think almost $1,500 a month, and that was over 20 years ago. And so we literally had no money. We used camping chairs, and I had gone to Home Depot, which is our hardware store, and built our furniture in our apartment. But we look back on those days, and those were the best days of our life, and we got out of the debt very, very quickly. Um, so I do feel like that is a good solution. Now, one of the things that was interesting, though, through all that, taking you back a little bit just before school, is I had my eye on the prosthetic and orthotic field for a long time. We had a friend of the family, Tony Plattner, who owned Plattner Orthopedic Company at the time, which has sold to Hanger Prosthetics and Orthotics. Um, so he allowed me to work there during the summers, and so I knew at an early age that I wanted to go into orthotics and prosthetics, and I've reached out to actually some prosthetic and orthotic schools and let them know, "Hey, this is my intention," that sort of thing. Um, After college, because you had to have an undergraduate degree, um, well, so I got rejected 3 times, to go to Northwestern University, for the prosthetic and orthotic, and that was a big blow to me and my, I guess, ego at the time. But I think it's nonetheless important to talk about because it was very competitive at the time to get into that program. And even though I had tried to cultivate and a relationship with the staff there for, I guess, almost 6 years before I applied, I got the same letter 3 times, but, everything happens for a reason, and I think this is interesting. I had the opportunity to go to California State Dominguez Hills, that same year, and being in Southern California was amazing. We made some lifelong amazing friends there, and I got to learn from some of the best, and people that we still refer to today, such as, Tim Stats taught our above the knee prosthetic courses, and those will always be memorable. So I would say also never give up too on that. I mean, it would have been very easy to give up on the dream of going into prosthetics and orthotics. So let's fast forward just a little bit. I got certified, all that, and I really want to talk about going into the digital side of things. I think the digital side of things is very interesting, and now schools are kind of coming online with the digital side. But starting early is very important, I believe, and really thinking about um, digital first instead of uh, cast and plaster first, and how you may achieve that. It could be a hybrid of sorts, and I we actually on the Prosthetics and Orthotics podcast, yours and I talked to Ben Wright recently, and he just went out on his own to start his own business. And I think this is an important fact: is that he decided that he was going to have a small office and use digital and try to maximize that. And he invested in a good scanner. A good scanner is the foundation of anything you do, and he ended up going with the Einscan H. So I'm gonna actually pull that up just so you can kind of see that. Here we go. Share screen. I'm gonna do this entire screen and do this screen share. Okay. So this is the Einscan or the Shining 3D, and they have a bunch of different scanners. And if you go down here, they have what's called a HX and then an H2. Both of these are great, and I tell you, they're also great for helmets. So I have been blown away at what is possible with this. I've tried a bunch of different scanners, and unfortunately, we had one of our. I still feel like it's one of the best scanners for helmets, which is the Polhemus Scorpion, but it's 25 year old technology now, but it's still great. But we had one of those go down, and we had to look at replacing it. And so the H2 is a great scanner. So getting started early on your digital journey is important. So the reason why I like these handheld scanners is that it gives you the opportunity to not only scan large models, but it also gives you the opportunity to reverse engineer. So if I had an opportunity to kind of just do it over again, I would automatically go and get something quality like this. Now, you also need to have another type of scanner, and that's one with you all the time. And one of my favorites here is the Comb Scan. It's on the iPhone, and it's iOS based. And I would look at an older phone, so like an iPhone 12 or an iPhone 12 mini. It's just a very nice size. And even if it's not the phone that you use on a daily basis, it's very inexpensive to pick up off of Amazon. And you're going to be right in the ballpark for AFOs and scanning of casts and that sort of thing. In fact, some of the pickiest, and I say that in the most loving term, some of the pickiest um, clinicians are ones that have used this, and we've been very successful in creating definitive sockets that way. So I think that's a great way to go. They also have what they call the fixture, and for AFOs. And so definitely check that out, especially now that we've got AOPA coming down the pike here soon. There should have some of that here. So check that out. Those would be two things that I would have. Now, if you're into the prosthetic realm, specifically for BKs, and I was extremely lucky to meet up with the guys from Coyote very early on in my career. And so I'm going to share. So this is the Coyote. So um, this isn't what I was going to talk about, but I love their dynamic struts. But if you go onto the Coyote's website and go to education, and then go to view courses, and you do this course right here called the StableFlex socket. This will literally change your life and the life of your patients. It is a great course, and I highly, highly suggest it. So I've had many friends of mine that have been in the field for a long period of time take this and say that it's even changed the way that they've practiced. So this is super important for confidence. So if you're a resident, new clinician looking to get into the field, whatever, take this course, and you'll see kind of the art and science behind orthotics or the prosthetic, specifically transtibials. But then you'll also be very, very successful that way. So that is what I would do. So check out Coyote. The last thing, I don't talk about advanced 3D much, and I probably should. I just don't toot our horn, I guess, enough, is definitely reach out to us. So if you're looking for getting into the prosthetic and orthotic space, 3D printing in whatever way, we're here to help you on your journey wherever that is. So if you need some help figuring out, hey, what am I going to do for scanning? What am I going to do for software? What am I going to do now doing test sockets or definitive sockets? Let us help you along the way. We have made a lot of mistakes, and I'm going to be sharing those along the way of things that we've spent money on that have been a learning experience and in some ways a waste. So I'm going to turn this back off. But Advanced 3D is a company that Paul, myself, and Tyler are a part of and started specifically for not only reaching the orthotic and prosthetic community, but if you have any engineering projects or design ideas, we can help bring those to life as well. So I'm going to stop this screen share here. So if I had to do it all over again, I would start with the scanner, and then I would go ahead and get software, and then I would buy a very inexpensive printer. So kind of the printer of choice right now, I would say, is the K1 Max from Creality. You get a 12-inch Z, so you'll be able to do pretty much all your transtibial sockets there. And then invest in yourself in training. So the software that I like is called Freeform Plus. You can actually do most of the things that you need to in Freeform. It's just that I use a lot of assemblies when I'm making some more of the complex devices. But there are ways around it in Freeform. Freeform roughly is going to run you about $12,000. So for under 20 grand, you could get Freeform, a Creality K1 Max, an Einscan H X or an H, and some training. And I think you are right on track with where you need to go. So that is one thing. And investing in yourself to do the design side of things is an interesting way to do it. And that's really where you're going to see the biggest savings. I was on a call yesterday doing an upper extremity prosthesis. And what was interesting about that is the person was kind of telling me what to do, and I was doing some of that live, and they were like, wow, that was fast. Well, I've spent a lot of time working on that to make it fast. But the beauty is that if you wanted to, you can get your parts to the clinically relevant part, which means in alignment with the adjustments that you need, and then hand those off to actually be fabricated. And I think that's a great way to go. And then at any time, you can look at doing the rest of it. But I think you're going to find that automation, specifically coming down the pike here, is going to let you not worry about, hey, what thickness do I need to do? How do I connect these two together? Oh, these transitions aren't looking right because the Boolean intersect or Boolean combine with a Boolean subtract doesn't necessarily work the way that it's supposed to. And so that is where I think things are going, and where I'm kind of banking on the future of um hey Amy, I'll get to that in just a second. um Banking on the idea of um, the clinicians doing clinical things, adding the meshes in, automation happening via multiple different ways. I think that is interesting. So, Amy, I'm going to answer your question here. Any thoughts on Orton? I think Orton's a great software. They're doing some really cool things on the scanning side of things. Everything is kind of like a combined ecosystem. Um, I like some of the stuff that they do in the regions. I know we have a couple clinicians that use it. I think for test sockets and such, I think it's fine. I think it lacks a little bit on the definitive side. I think there's specifically with powder bed fusion, um, there are some things that are design choices that are made that are can compromise um, the final product, and it's stuff that can be designed around instead of really relying on the material to do maybe not what it's supposed to do. So those are my thoughts on it. Some funny a funny story about that. So we had a clinician that wanted to do a partial foot prosthesis, but they didn't really have that as an option within the Orton app, I guess. So he created the whole thing. And the only way to export, you can't export out a mesh, which is a big time bummer, um, from Orton. And I think that if anybody from Orton's watching, that is a major would be a major plus, is be able to get those meshes out that have been modified and allowing clinicians to do what they want instead of having to take it all the way to the final product. Anyway, he used it to create the final product, and then what I did, and he put it in alignment and all that. So then what I did is brought it into Freeform, grabbed the inner surface, and made what needed to be made because it couldn't be done in Orton. So there's always a workaround in that, and that's the beauty of having Freeform and some of the software that we use, is that we can go in and grab just that inner surface and then make what we need to make. But it's a great way to get going, and I've got, you know, I think it's great. So and pretty affordable. Like the per download, what have you, uh, is fine. So that is on the digital side, is having that foundation done, and then what you can do as far as test sockets and that sort of thing. And I firmly believe in doing test sockets within your clinic. You're talking about a kilogram of PETG or less to do a below the knee prosthesis, which is, let's call it $15. So $15 or less, and in 4 to 5 hours on a basic computer. You got it, Amy. Thanks for asking the question. Um, so 4 to 5. Let's see, where was I? Hmm. I just lost my track looking at the comments. Um, if anybody remembers what I'm at, so I'm just going to keep on going. Um, so we talked about digitization. Well, I love being able to have full flexibility on the design side of things, which is why I suggest having a Swiss Army knife of any of a program that can literally bring anything in. You can keep it everything in its ecosystem and then build off of that. Oh, test sockets in a clinic. Thank you. All right. So test sockets in a clinic, 4 to 5 hours. That's what I was going to say. So they take 4 to 5 hours, and you're in for it for $15. So essentially, you could do same day, next day, depending on how you want to do it. And then if you want to do it faster, then you can buy a high flow machine, such as a Film Innovations machine, or like one that we're actually going to be releasing soon. But that will be a part of a package of with the software itself. So that's what we're looking at doing, and what a great way to create some cash flow for your office and quick turn. So the name of the game right now is, how do we get from the beginning to the end while uh, keeping patient care at the forefront, which is a compressed time, and cash flow at the same time. So the thing that we're seeing a lot, and that why a lot of people are calling us at Advanced 3D, is because a lot of contract manufacturers or central fabrication facilities have a timeline on specific items. So, like if you're looking to do a Click Medical adjustable dial or something like that on a prosthesis, you are going to be waiting a good amount of time. And so not only now do you have that, say, long period of time from your test socket to the patient, but you've also had money that's been paid out for components, and you're still going to be waiting for that socket to be delivered. Um, and it just becomes a money game. So that's where being able to 3D print some of this stuff in a fast way, emailing files back and forth, creating some automation, that's where things really start making sense for contract manufacturer for 3D printing for more complex things. So, like, I think of these Click Medical sockets as posterior panel here, something like this. You're taking your best tech, and it's going to take him or her a day to do it. Well, those back up. You may not want your tech doing that for a day, and so there's maybe there's something else that it would be better. Like, the reality is it would be better for him or her to crank out 4 to 5 sockets a day instead of one of these sockets a day. So the other neat thing about the Click Medical stuff is, now that it has a code, we get paid for the extra things that we do on the device. So not only is it better for the patient, but it also makes sense to spend the extra time to do this. And what a great application for 3D printing. The other application for 3D printing is for more of the complex devices, like what I showed you with the Coyote struts. So the Coyote strut style braces, again, it takes somebody that has some skill to make that in a traditional fashion. But if you can do that in 3D printing, and you free up your good technician to keep him or her from doing that, then it makes sense. And the other thing is that you have a digital file that you have for your patient. So if there is a failure of some sort, you're able to quickly make a judgment on why that failure happened and print a new one. So and those braces then become you're able to provide a higher quality product in a shorter amount of time for many times less money. So those are the types of things that I think about. One of the things that doesn't make sense for 3D printing is a solid ankle AFO. The only times that makes sense is maybe if you do an FDM base mode style AFO, and then it starts to make sense, but you still waste a lot of plastics. But if you do a solid ankle AFO in a powder bed fusion style printer, you're talking about $400 to $500 minimum, not including design, to get one of those out. It's just the wrong application for the technology. The reality is you're better off using a carving blank, or or pouring it down the way that you normally would, and pulling your $15 sheet of plastic and go from there. So that's what I really look at. The other thing that 3D printing I think is game changer for is upper extremity prostheses, and nobody has demonstrated that more than Chris Baschek at Point Designs. What he is doing is amazing. It's completely revolutionized partial finger prostheses, custom made to order, great fitting, low profile. And I actually did a whole podcast not only with Chris but with Jeff Solberg on that. So I recommend you check that out. But even for Chris had a beautiful shoulder disarticulation prosthesis that he made that used additive manufacturing, and there's just no way that you could traditionally fabricate that and make it have all the features that he had in there. So upper extremity prostheses, my personal belief is there is no reason to traditionally fabricate upper extremity prostheses. If you're not thinking 3D printing for upper extremity prostheses, I think I think you're missing the boat. And I'm going to say that about pediatric prostheses as well. If for whatever reason you are traditionally fabricating pediatric prostheses, it's the wrong thing. There is no reason to not 3D print a pediatric prosthesis. I can't think of one. Um, Traditionally fabricating a pediatric prosthesis means that you're intentionally putting something heavier, more bulky on a kiddo, and I don't think that's the right thing to do. And some people may disagree with me on that, but hey, let's have a conversation. But that's truly what I believe on that. And I know that's that's a hard thing to make a change if you've been doing it traditionally for so long. So let's see. I think I've covered a lot actually in the short amount of time. Anybody have some questions for me? If not, I'll keep on talking about some things that we're going to be doing at AOPA. Let me check here. I don't see any questions there. All right. So, um, all right. So a couple things that's going to be happening at AOPA that I'm really excited about is the Prosthetics and Orthotics podcast is going to be broadcasting live a few times from Charlotte, and we're really excited about that. I don't know how all that's going to work out, but it should be pretty fun. We'll talk to the people that I'm really excited to talk to are some of the people that around the coding and billing, some of the vendors and friends of the show, and clinicians that are making a difference in 3D printing. I think it's really important to note that we all have to kind of band together and encourage one another as we're doing this this move into the digital side of things. We get It takes all of us to make a big difference in the field. And what I'm really excited about is this younger generation of clinicians. I've seen nothing but amazing things from them, and they have amazing ideas when it comes to socket design, workflow, and even like on the lobbying side and the for lack of a better term, political side of things, really creating access for many individuals. It's very neat to see. So I would think I'm going to close with this, unless anybody has any questions. Is the idea of socket standards for prosthetic devices. So everybody looks at ISO 10328, and I'm going to try to pull this up because I think this is an interesting discussion. Okay. This is interesting. So why? Okay. I'm going to share this screen. So this is really important. And it just is what it is. Like, and this comes straight from ISO. Okay. Okay. So this is the abstract. I've also have the full document itself on the ISO standards. So anytime that you see a company say, hey, we are ISO certified with our sockets, you have to kind of step back and pause and say, what does that actually mean? So, and there's some companies that have done a good job with the ISO. Let's see if I can get this even bigger here. They've done a good job with the ISO standards, and the thing about ISO standards are it's a document specifically for components, for prosthetic components, to test not only failure modes, but then also cyclical testing as well. It's a pretty expensive test to do. Um, I haven't looked lately on the cyclical side of things, but the other thing that's interesting is, and somebody can correct me if I'm wrong, but so knees do not have a cyclical testing guideline. So, fun fact, if you need it for your bingo night or what have you. But I also find that this is interesting. So, with the ISO standards, is people create their own version of what they believe a socket should withstand. And so they'll look through the components and they say, hey, we believe that it should withstand these certain loading conditions and this cyclical testing. And kudos to them for using it. But it is very important to note this is what it says, and I'm just going to read it verbatim here. ISO 10328 is suitable for the assessment of conformity of lower limb prosthetic devices structures with the strength requirements specified in 4.4 of ISO 22523. Prosthetic ankle foot devices and foot units on the market which have demonstrated their compliance with strength requirements specified in 4.4 of ISO 22523 through submission to the relevant tests of ISO 10328 need not be retested to ISO 22675. So then ISO 10328, and we'll get to this warning here that's right in the middle of everything. ISO 10328 specifies procedures for static and cyclical testing strength tests on lower limb prostheses, which typically produce compound loadings by application of a single test force. The compound load in which test samples relate to the peak values of components of loading, which normally occur at different instants during the stance phase of walking. Perfect. So essentially, what it's saying is that there is a compound force that happens during the stance phase toe off loading area. And those are some of the things that they look at for component failure. But I'm going to make this big here. This is super important. It says warning, ISO 10328 2016 is not suitable to serve as a guide for the selection of specific lower limb prosthetic device structures in the prescription of an individual lower limb prosthesis. Any disregard of this warning can result in a safety risk for amputees. So, individual lower limb prostheses. So, I think it's not too much of a stretch that can be identified as the socket itself. There's no other individual part that would be made for the patient. So the ISO standards, which there is some things coming down the pike around the strength of sockets. But what they're saying is that if you use ISO 10328 to justify the strength of your socket, you might be missing the mark. Keyword might. And so I think this is where it starts getting very, very interesting on how people market the device. Because I myself, if something happened and failed, I don't know how I would handle the asking of, hey, were there guidelines that you followed? And saying that I followed ISO standards. I think probably the way that I would go is I would say something to the effect of there are ISO standards that are available for components, and there are some loading thresholds and that are in ISO 10328 that are valid thresholds. But I would not say that I used ISO 10328 protocol to test my sockets. And I think that is very important because they're warning you literally before you even get into the front page. Now, is ISO 10328 a good way to look at some of these loading conditions and such? Yes, but there is no discussion on how to actually load the socket itself. Do you use a soft mold? Do you use a hard mold? What type of machine are you doing? What type of load constraints are you doing? Are you going to failure? How are you going to do your cyclical testing? All that stuff matters. And I think the other part of that is this is not about 3D printing at all. And I think it needs to not be about 3D printing at all. The socket standards need to be the socket standards, whether you're going to use 3D printing or traditional manufacturing. And the reality is there is no standard for traditional manufacturing prostheses, which is why it's such a hot topic to get there right now. Is we need socket standards in general. And so I just found that to be interesting about the ISO standard. So that's why I always pause when somebody says we are ISO 10328 because ISO 10328 does not specify socket testing procedures. In fact, they say quite the opposite in their warning. But this warning is also a sign that there is heavy discussion on the back end of the ISO stuff, where there will be some socket guidelines coming out soon, and I'm excited for that. So let's summarize everything again. Invest in digital. Scanning is your foundation. And I'm not sponsored or anything by Shining 3D, but the Einscan H is a great one. Comb Scan is a great one. Use an iPhone 12 or an iPhone 12 mini for your best results. Software, you can outsource that. You can use something like Freeform, which is what I consider the Swiss Army knife. It's a one-time fee, and then you can pay for maintenance on an ongoing basis if you want updates. So those three, and then invest in yourself and in training. I didn't give some highlights here. So Derek Schmidt from Lemon Lattice has some pretty cool stuff on Mesh Mixer, and then Arthur Hobden has some great stuff: Fusion 360, Nomad Sculpt, ZBrush, and a few other low-cost options, and he's got some trainings to go along with you there. So I think that is also very important. Don't forget that. And then buy yourself an inexpensive printer, whether it's a smaller Bamboo printer or you get something that has a little bit more, we say Z height, so you can print taller things. And my preference there would be the K1 Max, and then you have the option to move into a bigger printer later on. With the K1 Max, don't mess with or any of these printers, don't mess with the 0.4 millimeter nozzle. Go ahead and day one. So pro tip, so you do want to change to a 0.8 millimeter nozzle, which is most likely the largest one that they make for the printer. But the pro tip is, do not switch that until you've turned it on and made all the things. So I made the mistake of opening the box and going to switch the nozzle, and it won't move. So it won't move into the place that you need. So I already had the nozzle, but I wanted to put it back in, and what a mess. So take it out of the box, set it up with the 0.4, immediately change it to the 0.8, and you should be good to go. That's and that's what I would do if I had 20 grand to spend. That's what I would do. I would buy Freeform. I'd buy an Einscan H. I would buy myself some training. I'd buy a K1 Max, and I'd be off to the races. And then just remember, Advanced 3D, myself, we're here for you. We are resellers of Freeform, and we also do training in Freeform. Speaking of, a lot of people ask me about other softwares as far as lattice structures and some automation stuff. Learn to design first, and then look at that stuff later. Probably one of the biggest mistakes that I made, and I don't know that it's a mistake because I learned so much and made so many connections, was spending quite a bit of money on this kind of lattice automation software for about 6 years. And that was a big mistake, I think. And what I was doing for myself, now that I look back on that, is I was looking for a shortcut. I was looking for the easy button. And the reality is if I would have taken the time to get myself trained up on a software like Houdini or Rhino Grasshopper, I would have been in a much better position than I am today. So I'm playing a little bit of catch up from that. So not only did I spend money for this and created workflows for myself that I was locked into spending this like subscription service, I never wanted to get myself in that position again unless I absolutely needed it. And so that's why I say, learn to design, make your clinical adjustments, and then go from there. And then for the students, residents, anybody else, try to do this in such a way where you don't take on a bunch of debt. you're gonna it's a long run, and then you're also gonna want to look for a mentor to get yourself in. Don't focus on the money is important, but on the residency side of things, focus on where am I going to see the most variety of patients, um, and just work your tail off for those 2 to 3 years and get as much experience as you can. And then once you do that, you can go in and specialize where you want to, but you at least have a great education that you can wrap your hands around and feel confident, really going and being independent in whatever you do. So that is more important than money, in my opinion. And if you're going to a place that doesn't do 3D printing, just know that if they're not 3D printing now, they're probably not going to be 3D printing anytime soon. And as much as I would love to say that you're going to bring them 3D printing, the reality is they need you to, um, also, for lack of a better term, pull your weight as far as, they're going to be paying a salary. They expect you to create some revenue at the same time, and either you'll be working on the scanning 3D printing in your off hours, or you might not get to it at all. So my suggestion is find somebody that's already at least halfway doing it or doing some of the scanning, if that is something that you're truly interested in. And I would say lastly, people ask about the machines, the powder bed fusion machines, and here's what I would say about that. Yes, Advanced 3D has, multiple multi-jet fusion machines, and I don't want to get into the reasons of all that. It wasn't that we wanted to have machines. I'll just put it there. We essentially had to learn how to use the machines, that we had. The reality is there is capacity all over the world in powder bed fusion machines, and you could get good pricing there. And so, you can leverage us for that. You can leverage somebody that's a little bit closer to you, but the economics of buying a machine for prostheses just does not work. Um, you will always be better off buying from a contract manufacturer that does this on a daily basis. And I'm happy to talk to you offline on real numbers of that. Some of the OEMs get kind of squirrely when you talk about real numbers, but I think it is important to note. And even for Advanced 3D, we spend six figures and more, more than $100,000. Probably this year it's going to be more than $200,000 in outsourcing our fabrication, for powder bed fusion. So if we're doing it, there's no reason for you not to be doing it as well. I would not have yourself saddled by hardware technology that is, continually changing, and but I would like to have the opportunity to play on all the hardware platforms, and I think that is important. So I hope this has been helpful, and I look forward to catching you in Charlotte. I'm going to check one more time for any questions, and then I will let you get back to your weekend. Cool. Yep, I don't see any questions. So, hey, thank you guys so much for being on and hanging in there with me. Thank you for encouraging me along the way on this, journey. It's always fun to be together as a tribe, doing some cool things, making a difference in patients' lives. So keep up the great work. Thanks again for all your, support, and we will catch you on the next Prosthetics and Orthotics podcast or beyond. Have a great weekend.